trig stuff to know. Okay, obviously, you should all know these or I'm going to cry. That 1 over sine is, oh my goodness, no.
Sorry, cosecant.
Oh my goodness, okay, 1 over cosine is what? What is it? Secant. 1 over tangent. Cotangent. And we also know that tangent x is, and cotangent is, okay. But we'll talk about derivatives in a second, but let's talk about some other things. So this is very important. You have to know all of these. These are called reciprocal identities. Reciprocal just means you flip the fraction, right? Need to know this guy. In your sleep, I have all of your phone numbers. When I call you at 5:30 in the morning and ask you what this is, you have to tell me. Okay. I don't know the other ones off the top of my head. I have to think about them. So if I divide every single piece here by cosine squared, cosine squared, cosine squared, what do I get? What's sine divided by cosine? Tangent, so what's sine squared divided by cosine squared? What is cosine squared divided by cosine squared? What is 1 divided by cosine squared? Okay, do the same thing, but now divide by what? Sine squared? Sine squared divided by sine squared. Cosine squared divided by sine squared. Cotangent squared. And 1 divided by sine squared. Cosecant squared. Like this? Do we know this? I don't know these. I can't remember which side the 1 is. Does the 1 go with secant? Does it go with tangent? Takes me a second. I do this in my head every time, okay? So if you know this one, you can get these. Okay? I want to show you something else. This is the derivative stuff. The derivative with respect to x of sine x is cosine x. The derivative with respect to x of cosine x is negative sine x. The derivative with respect to x of tangent x is secant squared x. Okay? Derivative with respect to x, let's do, okay, cosecant, hang on 1 second. What is it? Secant and cotangent. Okay, you may already know these. I sure hope you do. But let me tell you how I remember them. I know these 3 and I know this one. Derivative of secant is secant x, tangent x. Okay, now all of the cos have a negative. So I don't know what this is yet, but I know it's negative, and I know this is negative. All my cos have a negative sign. Okay? And cosecant sounds a lot like secant, right? So do you notice that secant and tangent are in this relationship together? They always hang out? Look at their derivatives. Okay, so what is the derivative of cosecant x? It's going to look just like this, but it's going to be these guys. Negative cosecant x, cotangent x. Okay, cotangent sounds a lot like tangent. The derivative of tangent is secant squared. Okay, so tangent and secant have this relationship. Cotangent and cosecant have a relationship. So what's this one? Okay, that's how I remember them. I know these 4, I guess, and I can come up with those just by thinking about it. All my cos are negative. Okay? A couple other things you need to know. You have to commit this one to memory. Sine 2x is 2 sine x cosine x. Commit that sucker to memory. Okay, so I'm just tell you all the ones I know off the top of my head. Okay, I know that cosine squared x is 1/2 plus 1/2 cosine 2x. And I know sine squared x is 1/2 minus 1/2 cos 2x. Your book actually writes it like this. As a fraction, one single fraction, but this is easier to manipulate. Okay, so you have to know these. Using these, I can derive some other things. If I use this first one, if I want cosine of 2x, I write that as, let's do 1 plus cosine 2x is 2 times cosine squared x. Do y'all see that? I'll multiply both sides by 2. Yes? I'm rearranging this to solve for cosine 2x. So I multiply both sides by 2, right? Okay, so if I want to solve for cosine 2x, I can then subtract 1. You'll see that? I don't know that off the top of my head. It just took me a second to figure it out. You get better at these and you can do these in your head, but do y'all see that? Okay. I also know that cosine squared plus sine squared is 1, right? Right? So I can take this one, cosine 2x, and instead of writing cosine squared, I can do 1 minus sine squared. Is that true? Is it cosine squared equal to 1 minus sine squared? Yes or no? So this is 2 minus 2 sine squared x minus 1. If you clean that up, what do you get? 1 minus 2 sine squared x. Okay. And you notice if you check in your book, there are 3 of them that are equal. So the third one is a little more interesting to derive. Let me just start with, I'll just start with this one. So if I look at cosine 2x equals 2 cosine squared x minus 1, instead of 1, I'm going to rewrite this as 2 cosine squared x minus sine squared x plus cosine squared x. Is it sine squared x plus cosine squared x equal to 1? So I can make that substitution. Clean it up. So 2 cosine squared x minus sine squared x minus cosine squared x. So if I clean that up, I get cosine squared x minus sine squared x. Does that make sense? Any other ones you need to remember? These are the ones that show up all the time. But do you see how, and you can memorize them, I'm not giving them to you. I'm not giving you any of these. But the ones I know are the ones I've starred. I know, what, 4 things? If I know these 4 things, I can come up with all these other things. These were very important in Cal 1 when you had to integrate cosine squared x. You didn't know how, right? So you integrated this side instead. This was a U substitution because it's a chain rule, composition functions. Okay, so we will stop here.